Hello and welcome to the second episode of this Explainable machine learning course. In this video we are going to speak about how to visualize a feature map or an activation map inside of a pre-trained neural network. Feature maps or activation maps are important to visualize the important feature preserved in each feature map. This can be useful at the early stage feature maps at the beginning of the neural network, because by going deep inside of the neural network the features are going to be more abstract, therefore we won't be able to understand it. So a feature map is going to be the result of multiplying the weights by the input image, adding to this the biases, and multiplying the result by the activation function, as you can see in this slide. So if we just plot the weights, that means we are plotting the filters. Maybe we will make another video to show you how to visualize filters. So let's go through the code to understand how to visualize feature maps. At the beginning, as this part of the code, we are just importing the helper packages. Here in the model, equal resnet 50 weights, equal resnet 50 underscore weights dot default. We are just downloading the model, the resnet 50 model, the architecture, and also feeding it with the pre-trained weight. Right now, we are having the model, and the model is equipped with a pre-trained weight. In these two lines of code, we are downloading the pre-processing steps that was used in the main training of ResNet 50, because if we are going to feed any image to the pre-trained model, we need to apply the same pre-processing steps which was made to the original pre-trained model. And just to download them, we are running these two lines of code. So right now we are having the model and we are having the pre-processing steps. So we need to transform the model into evaluation mode to be able to use it as a classifier. So this is our model. And right now let's test the classification capabilities of our model by feeding it with just random image of a peacock. So we need to have the file path to the input image. We are having the input path right now and open it using the pillow package. So this is our input image, a random image of a peacock or a cock. So we need to perform the pre-processing steps over our input image and to attach dimension to it in the first dimension. So if we look at the transformed image, which is named here image underscore transformed, we are going to see that it has an additional dimension here which has only one, and 3 dimension of colors, and then 224 multiplied 224, which is the same length and width of the images used in training ResNet 50. So the original image of the cock, which downloaded from the internet, had 576 as a length and 720 as width. So let's try and feed this transformed image into our classifier, into the pre-trained ResNet 50, and see if it can classify this image as a peacock. So we are going to use torch no grad because we are not training the model, but we are just using the feed forward method of the model, so we don't need to compute the gradients, and then feed the transformed image underscore transformed into our model, and then apply torch.softmax to get the neuron with the highest activation. So right now, and print the output of this. The 7th neuron, which represents the cock, was the one with the highest activation in the last layer. This means that our classifier is classifying images in a proper way. And if you are interested in making sure that the 7th neuron represents the peacock class, you can go to the PyTorch website and see the pre-trained models. Right now we are going to import the feature extraction package from PyTorch, and especially we are going to use the get graph node names to see the names of the layer inside of our pre-trained model. So we are going to import the get graph node names and create feature extractor class from PyTorch. The get graph node names is going to give us the names of the layer of the pre-trained model, and the create feature extractor is going to build a similar model to our model but equip it with forward hooks. These forward hooks are going to preserve and record the activations from each layer that we are interested in. So let's import them And right now we are going to show the name of the layer of our pre-trained model. So here we can see that layer 1 has many convolutional layers and patch normalization and activation. So we are having just 4 layers here. So I made a list and feed it with the names of the layers that I'm interested into visualizing some feature maps from them. And then I made an instance of the create feature extractor here, and the create feature extractor has 2 arguments. We feed it first with the model itself, the model that we are trying to understand its decisions, or we are trying to visualize its feature maps. And then in the second argument we are feeding it with a list of names of the layers that I'm interested in, or a dictionary. So if you are interested in writing it this way, the first use the dictionary form or the list form. Right now I'm having a feature extractor underscore x is a similar model to our ResNet 50 with everything but extra forward hooks, which are going to record the activations of layer 1, layer 2, layer 3, and layer 4. We can attach the hooks to ResNet 50 manually, or we can just use a pre-made feature extractor class from PyTorch. Here I'm going to the transformed image again into length and width and channel, and instead of patch and then channels widths and widths, we are going to change it again into the form of length and width and channel to be able to visualizing using Matplotlib. So this 2 steps are just for the visualization. And here I'm going to also use torsionograd because I'm not training the model. I'm just using the forward hooks which we added using the feature extractor class from PyTorch, and feeding the forward model with the transformed image. Here feed x is just the ResNet 50 attached to it some forward hooks. Right now we made our feed forward path, and the activations were saved in the forward hook. In this part of the code, we are just visualizing random feature maps from each layer, from layer 1, layer 2, layer 3, layer 4. So in each layer, we are just choosing some 4 random feature maps. Layer 1 is a shallow layer, while layer 4 is the deepest layer inside of ResNet 50. So let's see what is the difference between feature maps in the first layer and feature maps in the last layer. We are having our image, so let's save this here as feature maps. Save. Yes, replace. We are having the original image which we fed into the ResNet 50 here, and here are 4 random filter maps from layer 1, 4 random feature maps from layer 2, from layer 3, and from layer 4. So as an example, if we look at this filter map, we are going to see that the feature map is highlighting the body of the peacock while ignoring the face or the head of the peacock, while this one here maybe it highlights some sort of border of the peacock. This one is just highlighting some sort of feature in the background. This one here is also highlighting the head of the peacock and the back of it. Maybe this one is we cannot understand fully, and going deeper the features are more abstract that we cannot understand, and the 4 random filters in the 4th layer, in the deepest layer, are not activated at all. Maybe if we got another 4 random layer, we can see some activated layers. Maybe we're gonna have like a pixel here or a pixel here that are activated because of this input image. And by this we are ending our video. So if you are interested in explainable machine learning, please subscribe to our channel and like this video, and if you have any question, please leave it in the comment section. Thank you and see you soon.